Hi there. This is Lindsay, and I'm sorry I wasn't able to make it to the EarCoast conference, but here is a short demonstration of how my teaching team went through modeling an assessment. For this particular assessment, we are looking at an NGSS standard that is all about chemical and physical changes. This was developed for 8th graders. So the first step is to start with the NGSS performance expectation, which in this case is analyze and interpret data on the properties of substances before and after the substances interact to determine if a chemical reaction has occurred. The nice thing about the NGSS standards is that they are unpacked for us. So we always start with this particular sheet here because it's a really nice way of unpacking the complex performance expectation. So just to make it a little bit bigger for this video, when we look at that performance expectation sheet, we see that there are three kind of main core ideas that we're looking at. The students need to be able to show that they understand physical and chemical properties, the difference between products and reactants, and that atoms arrange to form new molecules. So this is the content that is found within that particular performance expectation. Then we also have the practices. The practices can be further broken down into 3 sub-practices here: making observations, organizing data, and then using data as evidence. So now we've unpacked our performance expectation, and just as a reminder, if you're new to NGSS, these come directly from these overall summaries, which can be found on the NGSS website. So once we know all of the core ideas and the practices that we need to assess, we sit down and we try to develop a model for how we can do that. For this particular assessment, it's open notes. We try to make as many of our assessments open notes as possible to reflect the authentic situations that scientists find themselves in. So that just means that the kids have access to their notes, to their computers, and we're really focusing on application of the ideas and practices rather than memorizing. Okay, so the first thing that the students do for this assessment is they watch a video of a chemical reaction. They come in and individually on their computers they watch a video, and they can watch it as many times as they like. Here's the video.
We'll go down the column on the periodic table in Group 1 and look at sodium. Like the lithium, the sodium is stored in a mineral oil to minimize reaction with the oxygen in the air. If we remove a piece of sodium metal, we notice that it's also coated over with an oxide coating. Group 1 metals become softer as you go down the column. The sodium is much easier to cut than the lithium. As we cut off the oxide layer, we can see the shiny metal underneath. It coats over very rapidly with a layer of oxide. The sodium is a metal and is an excellent conductor of electricity. If we take a piece of the sodium metal and add it to water, we notice a much more rapid reaction with the water. Like lithium, the sodium is less dense than water and floats. The metal moves across the surface, being pushed by the hydrogen gas that is produced. As you go down the column with Group 1 metals, the melting point of the metal decreases. The reaction is very exothermic, which causes the sodium metal to melt. The metal contracts into a very compact spherical form. We can again test that hydrogen gas is being produced by this single displacement reaction by trapping the gas and testing its flammability. We can test for the fact that we produce sodium hydroxide by adding phenolphthalein. The phenolphthalein turns a purple-red color due to the presence of the hydroxide ions, indicating the formation of the sodium hydroxide.
So as they're watching that video, they are documenting their observations. And again, they can watch the video as many times as they like. This is especially helpful for students with language issues or learning support needs. After they've documented their observations, we ask them to organize them into a data table. In the instructions for the assessment, we indicate that they need to organize by reactants, products, and that they need to show understanding of physical properties and chemical properties in their data table. They need to construct this data table on their own. And then the final component of the assessment is writing a conclusion. In their conclusion, they use the CER format to provide an argument for whether or not a chemical reaction occurred. That means that they need to make a claim about whether or not a chemical reaction occurred, and then use evidence from their observations to support their claim, and then use scientific reasoning in order to tie it all together. So that's just a brief model about how we went about designing this assessment, and you can see examples of student work, the entire assessment itself, and rubrics in the package provided. Now that we have the model in front of us, we can take a look at how the core ideas and practices are actually incorporated into the task. We check for understanding of the first two core ideas by looking at how the students have organized the qualitative data in their table. In order to really organize their observations by physical and chemical properties and by products and reactants, the students need to have an understanding of what these ideas mean. So we check for that in the way that they've organized their data table. The third core idea is that atoms rearrange to form new molecules. We look to see if they understand that by looking at the reasoning component of their conclusion. So in order to justify their claim that a chemical reaction has occurred, they need to explain that what's actually happening there is that the atoms are rearranging to form new molecules. Finally, we assess the practices as well. We assess the students' ability to make observations as they watch the video and record their observations of the various substances. We can assess their ability to organize data based on the quality of their data table, how clear it is with different headings, and then we can assess their ability to use data as evidence based on how well they incorporate the different types of qualitative data into their conclusion. So there you have it. Here's the model of an assessment task that we use for a particular NGSS performance expectation. Now, as teachers, we're ready to start planning the lessons and activities that will lead the students to this point. Thanks for watching.